Hi there, this is Math 148, section 10.3, still looking at these problems that are optimizing profit, revenue, cost, average cost, although you're actually minimizing average cost. And in the previous video I touched on these equations, but I'm going to go through a problem that uses these equations in this video. And here are the equations again. The average cost, C bar of x, equals the cost function divided by x, which is the mean. If you're in a statistics class, just take the thing divided by x, you get your mean. If you want the cost function and you have the average cost function, you can take the average cost function here and then multiply it by x to get the cost function. You're just rearranging this equation. So these are just different versions of the same equation. The revenue function is equal to P times X, where P is equal to the price or the demand in a monopoly. Because in a monopoly, there's no equilibrium point for price. You get to set your own price. So you look at demand. And the profit, here's another function, is revenue minus cost. And again, this makes sense if you're thinking your total profit is going to be how much money you take in minus the cost of running your business. So if I were a student in this class, I would definitely write these equations on my note card for test number 1. So keep that in mind. And I want to go over question number 37. From your homework, and this is very similar to example 5 on page 669, which is called Profit in a Monopoly on the 10th edition of the textbook. So here's the question. The weekly demand function for X units of a product sold only by one firm, they mean a monopoly, is given by this equation. P equals 600 minus 1/2 X, and the average cost of production and sale, so the average cost is 300 plus 3x. The questions ask you to A, find the quantity, so find the X value that will maximize profit. What is the selling price? So how much should you charge in order to make a maximum profit? And then what is your maximum profit? So here's how you work this problem. It's a bit long, but we can do it. And I wanted to go over it with you so you can learn to be clever and solve problems like this. So we want to maximize profit. We want to find some profit function and then maximize it. But we don't have the profit function yet. We're going to find the profit function by taking the revenue function minus the cost function. Here's the problem. We don't have the revenue function or the cost function either. So we have to figure out these separately. So the revenue function is going to be equal to the demand times X, or in this case, P times X. That's one of your formulas. So, go back to the problem. P is 600 minus 1/2 X. So our revenue function is going to be P, this part, 600 minus 1/2 X times X. Yes, you can see this. It is 600X minus 1/2 X squared. And then the cost function, I'll keep it in red here, we were given the average cost, if you look at the problem here, average cost of production and sale, so we want to use the cost function, not the average cost. So the cost function is the average cost, C bar of x, times x. It's a lot of multiplying by x. So this is 300 plus 2x, that was the average cost, times x. Now, where are they coming up with these functions, the demand function and the average cost function? Well, don't worry about that for now. 2x squared. Just going to work with the functions as given. We have enough on our plate. So now we have the revenue function here, 600x minus 1/2 x, and we have the cost function. So we are back in business. So to find the profit, we take profit of x. The profit function is equal to the revenue function, 600x minus 1/2 x squared, minus the cost function, which is 300x plus 2x squared. And this all equals, when you are done, equals 600x. Oops, sorry. I'm just going to skip a stage here. So these, you get 600 minus 300. That's going to be 300x. And then you have half an x squared and minus 2x squared. So it's minus 2.5. You could say 2.5 x squared, but 2.5 is a little bit clunky. So we're going to say the profit function is 300x minus 5/2 x squared. So we want to maximize this function. And in terms of derivatives that you guys have been working with, this one is not the nastiest one we have. I'm going to pause it here and get a new page. Hold on. Function again, we want to find the maximum profit. You want the maximum profit, people. So we're going to take the first derivative, p prime of x. That's going to be equal to 300, take the derivative here, minus, you take 2 times 2, so the 2's cancel, and you get 5x. So this is going to be maximized. You set all of that equal to 0, and the solution there is x equal to 60. That's so tidy. Doesn't it warm your heart when you get a nice simple solution? It always makes me very satisfied. So what we've determined is that we have some sort of critical point at x equals 60. So technically we have not confirmed that this is a maximum. So critical point. I'll say critical point. So how do you confirm that it's a maximum and not a minimum? So there's a couple of ways to do that. One way I like to think of is you can say, well, let's take the second derivative. Why would we do that, Kate? I'll show you. The second derivative, so take the derivative of this piece, 300 minus 5x, is minus 5. I did that because that's an easy derivative for me to take, and you'll notice that's always less than 0. So that means we have a function that is always concave down. So if you were trying to prove your work here, you could use this proof. It's always concave down, which means 60 must be the maximum. So 60 must be a maximum because it's always concave down. Must be a maximum. I think that's the fastest way. You could also use the sign test by saying here's 60 and then saying, well, it goes up on this side, doing the first derivative test by putting a number in here in the first derivative. I think this is faster. Or finally, I would also accept a basic math 116 answer, which looks, I'm trying to pick a color. I'll try this weird green color, which you could say this profit function, p of x, it looks just like yellow, is minus, I'm just rewriting it like this, 5x squared plus 300x, which is a parabola. We just figured that out here, which opens down. If you took math 116 or you're really good with parabolas, you'll say, the x squared coefficient is negative, so it's a downward opening parabola, so we're back to this concave down thing, so it must be a maximum. You could also try this by graphing. So all I've been doing here is confirming that this is in fact the maximum profit and not the minimum profit. So part A says what x value maximizes profit. So if you produce 60 units, that maximizes profit. So that's the answer to part A. Part B says what price, go back to the problem, find the selling price at this optimal quantity. So now we have the optimal quantity, we can just plug it into these equations. So the selling price is here, P there, I'll plug that in. So in order to find the selling price that maximizes the profit, we have 600 minus 1/2. I'm just plugging this into the price function. That used to be an x, now it's a 60, and that gives us $570. So you're saying, what should we sell it for in our monopoly? $570. There's your iPhone 6 or whatever. Doesn't that seem like about how much an iPhone 6 is going to cost? And then part C says find the maximum profit. So I'll make a little box around all my 60, 570. So what is your maximum profit? I don't know if this is per year or per month or whatever. But our maximum profit, we're going to just plug x equals 60 into this profit function right here. Our profit parabola. So we're going to take 300 times 60 minus 5/2 times 60 squared, and all of that equals 9,000. 9,000. So quick review of this problem. It said find the quantity that will maximize profit. 60 is the answer. What is the selling price at this optimal quantity? So we're saying we should sell them for $570. And finally, what is the maximum profit? $9,000. You could also do this if you wanted to graph it. See how I graphed the profit function? I still had to find the profit function first, but once you find it, you can graph it, and then you can prove that that's the maximum 60. You're making 60 units and you're making $9,000 profit. So 60 units give you $9,000 profit, and then you'd still have to figure out this $570. So that is an excellent problem to know how to do. If I put something like that on a test, oh, I would probably make this one be worth it maybe 15 points, because that's kind of a long problem. So go over something like this and let me know if you guys have any questions.